Hello everyone, today we are going to have a quick review about the types of data structures. So amongst the type of data structures we have linked list and its three types. Then we have the stacks and queues and the special types of queues. And we'll talk about trees and especially the most commonly used tree, that is the binary tree. Then we have graphs, which can be either a directed graph or an undirected graph, right? So let us try to have a better understanding of these concepts. Firstly, we go have linear linked list. In linear linked list, also known as one-way linked list, the node consists of two parts, the data part and the pointer part, right? So the pointer part of the node consists of the starting address of the next node, and if the pointer part or the link part of the node consists of null, then it is the last node of the linked list, right? And the only way to traverse this linked list is from the start. That is, if you want to traverse node number 3 or node number 2, you have to start from the first node and reach that node to do any modifications like deletions or updations or printing for that matter, right? So the next is circular linked list. So just like a linear linked list, circular linked list behaves the same way, where a node consists of two parts, that is the data part and the link part. The only difference between the one-way linked list and circular linked list is that the last node of the circular linked list contains the starting address of the first node, as you can see from the figure, right? So this makes it circular as the last node is pointing towards the first node. Then we have double linked list or two-way linked list, right? So a two-way linked list consists of a node which has three parts, that is the part of the data part, the data part and the two link parts, one pointing towards the forward node and one pointing towards the backward node. The forward node and the backward node, as the name suggests, contains the addresses of the next node and the previous nodes respectively. And if the last node, the next pointer of the last node contains null and the back pointer of the first node contains null, then it is a doubly linked list. And vice versa, if the next pointer of the last node contains the starting address of the first node and the back pointer of the first node contains the starting address of the last node, then it becomes a cyclic double linked list or cyclic two-way linked list. The next concept we are going to talk about is stack. Stack is just like when you are placing books in a piece of in a cupboard, one stacked one on top of the other, where the first book that you stack is at the bottom. So when you need to take it out, you have to pick out all the books that are on top of it. So you can also call it last in first out or first in last out, right? And inserting anything into a stack is termed as push in data structures. So this particular animation was of push or inserting elements onto a stack. Similarly, deletion from a stack is termed as pop. So this particular animation is telling you about the pop, where the second last node can the link part of the second node becomes null and the nodes keep on terminating or exiting. So these are some small animations on push and pop. Then we have the concept of queue. Queue is just like when you send the line to submit some application or some fees or anything, right? And what happens over there is the one who comes first stands first and the one who comes last stands last. And or in other words, the one who comes first is served first. We also call it first in first out or FIFO. And the one who comes first is at the front and the one who comes last is at the rear. So insertion is done at the rear and the deletions are done from the front, right? Deletions are done from the front, as this animation is also showing you. The insertion was happening at the rear and deletion is happening at the front. Then there are two special types of queues, dequeue and priority queue. A dequeue or double-ended queue is a linear linked list can be is a linear linked list in which elements can be added or removed from the front end or the rear end, but not in the middle. So what is the difference? In a queue, elements can only be inserted in the rear and can only be deleted from the front. But if it's a dequeue or a double-ended queue, elements can be added or deleted from the front end also and the rear end also. Hence the name dequeue, double-ended queue. The another type of special queue is priority queue, in which every node is given a priority or based upon which it is placed in ascending or descending order, and the priority decides the order of execution, the order of termination, the order of servicing, whatever you like to call it. The higher the priority, it is processed before the lower priority orders. And if we have two elements with same priority, then the element that was inserted first would be entertained first. So moving forward, let's talk about trees. A tree is a non-linear data structure which is mainly used to represent hierarchical relationships, right? There can be binary tree, there can be ternary tree, and so on. As the name suggests, binary tree means two branches, ternary tree means three branches, as this figure is showing you. The mostly used trees are binary trees, where every node can have a maximum of two subnodes, hence the name binary. That does not mean that the node cannot have one subnode. It can have one subnode, but the maximum it can have is two subnodes. So graphs are structures which in where nodes are connected with each other, right? Every node is called can also be called a vertex, and the connections are called the edges or the arcs, right? the, as you can see, there are two graphs over there. One is directed graph. The first one, that is the graph on the top, is the undirected graph, and the graph at the bottom is the directed graph, right? Tree can also be considered as a type of a graph or a subgraph, but where there are no cycles. As you can see over here, a graph can complete a cycle and it is cyclic, but trees cannot be cyclic. So undirected graph, as in shown in the top graph of where the nodes are 1 2 3 4 5, is sometimes also zoomed to be bidirectional, right? Or when it is replaced or represented in directional way, then you need to place two arrows over there. And the directional graph is simple, as you can see over here in the bottom graph. It is a directional graph, and each node is directing towards the other given a directed arrow, right? So that's it. Thank you very much. I hope you like it. Don't forget to subscribe. Thank you.